Hello, welcome back. I'm Benjamin Williams, and today we're going to be doing another Boson NetSim lab. Today we're in the infrastructure section within Boson, and we're going to be doing some EtherChannel negotiation protocols. We're going to be working with EtherChannel today, a layer 2 protocol. We're going to be doing PAgP, which is a Cisco proprietary protocol. You have LACP, which is Link Aggregation Controller Protocol. That's a standards EtherChannel negotiation protocol, but we're going to be doing something Cisco proprietary today. So our objective for this lab, it says you will plan, implement, and verify layer 2 EtherChannel configurations in this lab by configuring EtherChannel between two switches using the port channel aggregation protocol negotiation protocol. So here's our lab topology. We have a lot of Ethernet switches in this lab, of course, because we're going to be doing a layer 2 configuration today with EtherChannel. A lot of redundancy, and of course you have to have redundancy in order to configure EtherChannel. Basically what we're going to do is we're going to combine two of these physical cables into one logical cable. So when you look at it from a spanning tree perspective, it's going to operate as if it's one link connecting these devices, but it's going to be two links, and it just allows for more throughput through that link because it'll be one logical link. You can combine both physical links bandwidth into one, and it can be up to 8 links. So EtherChannel is a very cool protocol, and I think it's definitely an advancement and something you could take advantage of. So it says task 1, it says plan EtherChannel configurations. And by the way, we did read through all of the commands for this lab and all of the descriptions. So we're going to go ahead and jump straight into the lab task. We're going to keep our topology up here in the top left. We're going to read our instructions right here in the top right. And we're going to be doing all of our CLI configurations down here at the bottom. So let's go to task 1. It says this task involves planning layer 2 EtherChannel configurations using negotiation protocols. In this lab, you will be assigning physical interfaces to a channel group and using port aggregation protocol to form an EtherChannel between D switch 1 and D switch 2. So we're going to be doing this link right here. We're going to be combining these two physical links into one logical link with the port channel. So it says, what is Cisco's proprietary aggregation protocol for EtherChannel and when should it be used? Well, Cisco's proprietary protocol is PAgP, or port aggregation protocol, and when should it be used? It can be used on between two switches that have some redundancy between them. So if they have two physical links connecting them, then you can do an EtherChannel. Now, if you only have one physical cable connecting them, you can't form an EtherChannel. It has to be 2 or more. And both of those interfaces have to be configured in the same way. So they have to have the same duplex. This is the same configuration. If they're trunks, they have to match. Certain things have to match in order for it to be able to be configured as an EtherChannel. It says, what is the standards-based aggregation protocol for EtherChannel and when should it be used? The standards-based is LACP. And it basically has the same thing. It should be used if you have redundant links between switches and if they're configured to be the same. They have to have the same configuration in order for EtherChannel to be formed. List some of the factors to consider when determining which EtherChannel aggregation protocol to use. Really, it just depends on if you have all Cisco gear or if you have other gear. If you have Cisco and other gear, you'll have to use LACP. If you're using all Cisco gear, then you can use PAgP. It really just depends. And then, of course, all interfaces have to be configured the same. All right, number 4, can more than one EtherChannel protocol be used in the same EtherChannel? No, only PAgP can be used or LACP. You can't combine both of them. So, no, you cannot do that. Number 5, what happens to a physical interface when you make a change to a port channel? Well, if you change the port channel, the physical interface will abide by the port channel rules. But if you change a physical interface that's within the port channel, it may change the configuration to where that physical interface is not involved within the port channel anymore, and then it'll be taken out of the port channel. So you don't want to make any, if you have an interface in a port channel already, you want to make changes to the port channel itself so it's abides to all of the physical interfaces, not make a change to the physical interface, and then that'll make a change to the physical interface, which might take it out of the port channel. All right, number 6. Can ports in different modes form ether channels? Yes. So if you have a, let's say if you have a PAgP port that is in auto mode, it can form, I think it's auto and what's the other one? Desirable, yeah. So if you have a port in one of the links is in auto mode and the other one is in desirable mode, it will form an ether channel. But if both are in auto mode, then they won't form an ether channel. So you have to be on the lookout for that. It says, what command can you issue to determine the number of links that are available to form an ether channel? You can do show CDP neighbors to see all of the directly connected devices, and then from there you will know if you were able to use that link for ether channel or not. So you just do show CDP neighbors. So initial, it says number task 2, it says review initial configurations, and this task involves performing layer 2 ether channel configurations. It says number 1, determine the number of links that can be configured as part of the ether channel. So let's go to dswitch 1 and dswitch 2, because that's where we're going to be doing our configurations at. And let's do an enable to go to privilege exec mode, and let's do a show CDP neighbors. And we can see right here that for dswitch 2, we have the fast ethernet 05 and fast ethernet 06. So we're going to be configuring both of these to be in the ether channel. Let's go to dswitch 2, let's do an enable, and let's do a show CDP neighbors. And we can see that we have a connection in dswitch 1 from dswitch 2 for the fast ethernet 05 and fast ethernet 06. So I think it's the same connections. Fast ethernet 05 and 06 too. Yep. So let's move down, bring up our, okay, perfect. So it says display the line and protocol state of each interface on dswitch 1 and dswitch 2. So let's do a show IP interface brief. And we don't have any IP address information up here. Let's do a show IP interface brief. Oops, didn't spell that right. Brief. Show IP interface brief. And we have no IP addresses on any of these interfaces here. They're all in the down state. Well, they're all in the up state. They just don't have any, for the fast ethernet, I should say. The gigabit ethernet, they're in the down state. But most of our fast ethernets are in the up state. They just don't have any IP addressing. So it says, verify that an active trunk exists between dswitch 1 and dswitch 2. Which trunk encapsulation type are both switches using? So let's do a show IP. Well, let's do a show interface trunk. All right. And we can see right here, it says verify that the active trunk exists between dswitch 1 and dswitch 2. So we want to look at the fast ethernet 05 and 06, and we can see our status is trunking, and we're using ISL instead of 802.1q. Let's look at dswitch 1. Let's do a show IP, well, no, show interface trunk. Okay, fast ethernet 05 and 06, we see that both statuses are trunking, and we're in ISL mode over here as well. So it says verify that all ports are identically configured. So let's do over here. Let's do a show run. Let's make sure our fast ethernet 05 and 06 are configured. Okay, so there's no configuration here, so they're configured to be the same. Let's go over here. Let's do a show run. And fast ethernet 05 and 06 right here, they're configured to be the same. So that's perfect. So they should be able to form an ether channel. So it says configure ether channel by using PAgP. So it says on dswitch 1 and dswitch 2, configure the fast ethernet 05 and 06 interfaces to use port aggregation control, port aggregation protocol as the EtherChannel negotiation protocol. So let's go here. Let's do a configure terminal to get into global config. Let's do an interface range fast Ethernet, because we're going to be configuring two interfaces, 05 through 6. We want to do both of those interfaces. And then we're going to do a channel, if I can spell, channel group. No, we need to do a channel protocol, because we want to do the protocol first, and we want to do PAgP. Perfect. Let's go over here to dswitch1, and let's do a configure terminal into global config mode. Let's do an interface range fast Ethernet 05 through 6, and let's do a channel protocol of PAgP. Perfect. All right, on dswitch1 and dswitch2, configure the fast Ethernet 05 and 06 interfaces as members of port channel of channel group number 1 by using the auto mode. So let's do a channel group of 1, and let's do a mode of auto. Alrighty, so we can see that our port channel was created right here in the syslog message. And let's do a channel group number 1 mode auto over here as well, and we can see our port channel is created. So it says verify that the new automatically created port channel number 1 interface exists on dswitch1 and dswitch2. So let's do a do show IP interface brief, and we should see our port channel here. Yep, we see it down here. Perfect. All right, let's do the same thing. Do show IP interface brief. And it's still showing it in down state because we have both sides in auto mode. We have to configure one in desirable in order for this port channel to come up and start operating. So it says, step 4, it says, configure the port channel number 1 interface to unconditionally trunk using 802.1q trunk encapsulation. Let's go to dswitch1. Let's go to interface. Let's go into interface port channel. Okay, let's do an exit. Let's do an interface port channel so I can get my context sensitive help and number 1. And then we want to do encapsulation. Okay, we can't do encapsulation. So let's do a context sensitive. And let's do a switch port. That's what we want. Switch port mode trunk. Then we want to switch port trunk encapsulation dot 1q. And then we want to do a switch port mode trunk. That's what we want to do. All right. Let's do an exit. Let's do an interface port. We're going to do the same configuration over here. Port channel number 1. Let's do a switch port trunk. Let's do a switch port trunk encapsulation dot 1q. And let's do a switch port mode trunk right here. All right, got that done. On dswitch1 and dswitch2, display the state of the port channel and its member interface ports. Or interface fast Ethernet 05 and 06 bundle in the port channel. If so, why not? Well, we know it's not bundled in the port channel by using this command, but we can do a do show EtherChannel summary, and we can see that it is not bundled. We have the eyes right here, which means they are standalone ports. And SD, we have S and D, which means S is layer 2. It's saying that we're working with layer 2, which we are. And D means down. So this is down, and the reason that it's down is because we have both sides in auto mode. We need to configure one in desirable mode. So right here it says on dswitch1, configure the fast Ethernet 05 and 06 to use port channel desirable mode. So let's go over to dswitch1. Let's do an interface. Let's do an interface. Let's do an interface range fast Ethernet 05 through 6. Let's do a channel group number 1. Let's do mode, and let's do a desirable. Perfect. Now let's do a, and we see our, like I said, our line protocol for our port channel is now up. So that's good. So on D switch 1 and D switch 2, verify that the line and protocol state of port channel 1 are both up. So we know it's up because we just got that syslog message, but let's just confirm. Let's do a do show IP interface brief. And we can see that our port channel right here, number 1, is now the up state, which is what we want to see. Let's go over to D switch 1. We have those same syslog messages in our console, which is what we want to see. It's in the up state, but let's just do a do show IP interface brief. And we see that this port channel is in the up state, so perfect. On D switch 1 and D switch 2, display the state of the port channel and its member interfaces, or Fast Ethernet 05 and 06 bundle in the port channel, so they should be. Let's do a do show EtherChannel summary. All right, and we see that they are bundled. The P's mean that they are bundled in the port channel. That U, the capital U this time, when in the SU means that we're in use. And the capital S, as we said last time, this means that we're doing layer 2 ether channel configuration. So that is perfect. Everything looks good on D switch 2. Let's just confirm over here. It should be the same over here. Show ether channel summary. And we have the same thing over here on D switch 1. So everything looks to be correct. Let's go ahead and hit grade, see if we got everything correct. And we did. So everything is correct over here. So this will conclude this lab. Thank you guys for watching this one on EtherChannel. See you in the next one.